Okay, thank you. I struggled trying to figure out what to demonstrate this month. I tried to figure out something new each year, each February, and was having trouble, but I resorted to the biggest resource that anyone could ask for, and that is the back issues of the American Wood Turner. I went back 5 years. This is August 2013 issue, and I just was skimming around and I found this article on these things. He called them Streptohedrons. So I started to get into it more, and I found out that this book from the Cuyahoga Library by David Springett is available, and I've gotten through the first 2 chapters. So I've done all the easy ones we're going to show today. And really, the turning itself, the turning techniques are very, very simple. You're making straight lines and simple curves. Number one, design them unless you copy exactly one for one his designs. And 2, you have to be accurate. If the straight line is supposed to be 20 millimeters and you're 19 millimeters long, it's not going to be that good. If it's 19.5, you could make it work with a little bit of sanding after you're done. So most of the turning itself is pretty easy, and I'll show that after I give you a 10th grade geometry lesson. What we're going to do, we're going to have 2 blocks of wood, going to glue them together. Going to turn it round, going to make the shape, and you're going to split the wood at the glue line and back into 2 pieces, and then you're going to put the pieces together in a different way. You're going to rotate them. So this is an example. This is, I turn this shape, it's a hexagon in cross section, split it at the glue line, and then when you put it back together, you twist it, and it makes an interesting shape. And the word streptohedron means twisted polyhedron. So strepto means twisted. So that's what we're making here. Let's start with the simple ones. The top one is a equilateral triangle. Okay, so this is the turning axis here. All 3 sides of an equilateral triangle are the same. I marked them A here. But the height of the triangle, which is the distance on the spindle, along the spindle, is multiplied by 0.866. So it's a little bit, I forgot what that is. The square root of 3 divided by 2, I believe. But anyways, from geometry, this is known. So you're going to make a triangle, and after you split the triangle on the glue line, you glue it back together with a twist. It looks like this. Okay. All right. And if you try this, you'll notice it's a one-sided piece. You never hit an edge. When you cover the entire edge by running your finger around, you get to the whole end without hitting an end. So anyways, this is a triangle that what I call a single cone. Most of the easy ones are called regular polygons, okay, where all sides are equal. But I'll show you how you can deviate from that. The next one is a square in cross-section, but it's a cylinder when you turn it. Okay. After you split it, put it together, it's kind of weird looking. Okay. All right. And I think this is the first one that will wobble when you roll it. Let me try this. This is called a Sphericon. This has a specific name. The guy who invented this one got to name it. He named it a Sphericon. It's a double cone. It's 2 cones put back to back. This is the glue line and the turning axis. When you put them together, twist it and glue it together, it looks like this. Okay. This is the one I'm going to demonstrate first. It's one of the more interesting ones. The next one then are these hexagons, and you could do a hexagon 2 different ways. You could do it with the points on the turning axis or with the flats. And all the math is here, but basically again, in this direction the length is equal to the diameter. Makes it easier to do. If you do it this way, you have to multiply by that 0.866 again. After turning, sanding off the glue line, twisting it 30 degrees and gluing it back together, it'll look like this. After gluing and sanding up, it looks like this. So I'll send these 2 around together. Now you'll notice when you put this together, there are slight deviations between the 2 halves. That means my turning was not perfect. However, this is pretty accurate. I'm pretty accurate on this one, and sanding this to make it perfect, which I'll demonstrate later in the day, is probably only 5 minutes. Okay, so you can do other shapes too, like a pentagon, not just even-sided pieces. I didn't try one of those. But what I did learn is that you don't have to do a regular hexagon. All right, so in this case, I call it an irregular hexagon. That means all the sides are not equal. This distance from here to here is different. The thickness, I called it, versus the height, different sizes. And you can make this work as long as your length of the whole total piece is equal to the diameter of the total piece, and h is equal to t. Okay, so this, I guess h and t are the same, but this diagonal is longer than either h or t. And the left side has to be symmetrical to the right. So those are the rules. And this is an example of one of these. Okay. This width of this side is different, shorter than this dimension. When you put them together, it's an interesting variation from a regular hexagon. Now you can take this farther, this concept of unequal sides, and you can do different things. And the first one, which is on the cover of that AAW magazine, is called a Fem Sphere. And instead of sharp angles, you have a curve. It's actually a radius of a circle. And again, you can make this work if the length is equal to the diameter, and the thickness at the top is the same as the thickness at the sides. So we're going to make one of these today. Okay. And then finally, you could make one that is stepped. And if you follow these rules that are written on this sheet of paper, again, length is equal to diameter, and all these dimensions have to be equal, you can make a weird-looking four-stepped piece. Now, this one here looks like this when it's done. This is my first attempt at that, and I did the math incorrectly. I was using the radius instead of the diameter, and I got these dimensions wrong. So you can see that this dimension is supposed to be equal to this one, and it's way off. And that's because I just did the math wrong, and I got it right on this one. So you can compare those two. So for the one that's called the Hemisphere, we'll demonstrate that later today. Here's a finished one. Okay. Here's an example of I got a marked A, there, A and A. These two, when you put them together, you'll see they're left and the right and the top and the bottom are not matched up very closely. Part of that's because it broke on the spindle before I was finished. And this was lace wood. It's not as strong as the cherry, so I switched to cherry. But anyways, you'll see that this cross-section is relatively poorly done. If you compare B and B here, these two match up excellently. You can see how it was turned and how you twist it here, and you can see that only a little bit of sanding will be needed to match it up. Okay, so look at that, and here's one that's glued up but not yet sanded. This is not quite as good as the BB example, but it's tolerable, and I'll sand this one today. And I have two completed ones. So those are the designs that I'm going to be working on. Now, the first thing we need to do is you need to have a glue block. Okay? These were glued up by Tom Olachu. He's still here? You left already? Oh, okay. This is two pieces of poplar, and they're glued together with a piece of paper in between. You could use newspaper or brown paper bag. Okay? This holds pretty good, but it's not perfect. So when you're all done, you'll stick a chisel there and a light hammer tap, and it'll pop open. Okay? Now, if you go through YouTube videos, you'll find people who don't like the paper joints. They like to use hot glue instead, or double-sided tape. But both of the guys who did that warned that the samples fell apart on occasion when they were turning. So I don't recommend that. I recommend the glue joint, and it's actually easier to separate when you're done with a paper joint. And I'll show you how to do that here. Now, if you do it wrong, here's an example. This piece was glued together, two halves, like this, glued together with a paper joint. I put it on the lathe between centers, and the pressure from the centers caused it to split open. Okay, so that's one of the problems. You have to have the right type of points so that it doesn't split. And what I've done is I've just removed the corners between centers, and I made a tenon immediately, and I stuck it in a jaw, 4-jaw chuck. So once it's in the jaws, it's not going to split, so this is much safer. So this is what we're going to use today. We're going to have them already turned for fitting in the tenon. So the idea here is not to put too much glue, just enough to evenly spread between the two pieces. You don't want the glue to thoroughly saturate the paper. Okay. All right, that's fully covered. Need a little bit more. Okay, I'm going to use a piece of Giant Eagle paper bag. Again, newspaper. I think newspaper is a little bit of a weaker joint and it's easier to split. On a gentle or a fragile piece like I have here, newspaper is probably even better. But I'm going to use this craft paper here, and you just... Want to help me crank that down, please? Okay. All right. So that's it. Now you wait till about it overnight, and you'll be able to do it. Now, the top and the bottom pieces, the way Tom did it, they're perfectly matched up. He probably trimmed these up a little bit. Mine are off a little bit. I could worry about that and adjust it, but I think it'll be just fine, even if it's off a little bit. All you have to do is square it up when it's fully glued. But basically, once you have this glued together and it's dried, you want to mark the center. This way is you can be a little bit off, but you have to be exactly on the glue line with your point. Exactly, or else it's not going to work. Now here, obviously, if you have a point like this and you're sticking it in there, you're going to be driving the wood apart. Okay, so it's much better. You can make this work. Sometimes you might actually even drill it a little bit in to provide some relief. But this type of point is much better, much more forgiving, because the whole entire cone section will be sticking into the wood and holding it together. So this is what I used at home to round off these pieces. So here's more examples of this. Here's a walnut piece. Again, I didn't round it off, take off all the corners, just enough to get a good tenon on the one side. Here's another piece of cherry that we'll use. I do a lot of my pieces that I practiced on were this 2-inch diameter range, but there's really no limit. You could make them up to 3, 4, 5 inches if you wanted to. So we're going to make the first one. I like turning between centers. Make sure the center is in the pre-existing hole. I tighten it up. We're going to make the Sphericon, which is the double cone. We're going to make this one here. So basically we want the length equal to the diameter. Okay. First thing we'll do is going to turn it round. Let me talk about my tools a little bit. You could do the whole project with only 3 tools. One is a roughing gouge, spindle roughing gouge. Second is a spindle gouge. Okay. Now you'll see the way I grind it, I grind the heel off. So I grind the heel off. That helps with clearance a little bit. And the third tool you'll need is a parting tool. And this is a plain diamond parting tool. This is a Thompson tool. But I have 2 other parting tools that I like to use. This is a Bedan. Tom introduced me to this tool, and I find it cuts great. A little bit scary how easy it cuts, but it's really just a thick parting tool in many ways. But this angle, it peels wood very, very quickly and efficiently. And then the other parting tool that I just got for Christmas, and just starting to use it, is a Nick Cook parting tool. And this has a flute down here, a flute parting tool. So that also cuts very cleanly compared to other tools. And we just started to experiment with this, but it looks like it's a winner. Okay, so the first thing we're going to do is we're going to round this off. Now at home I used a powered respirator, just like Tom demonstrated last month. It's got a fan that you tie around your belt, blows air through a filter and then up through your headset and down across your face, so it keeps things clean. I experimented with it, and I don't think I can get the microphone on, so I'm using this less expensive version. Okay, I'm anchoring the tool handle onto my waist. I've got the handle below level. Bring it up, I'm rubbing the bevel. I'm anchoring it on the tool rest. I'm rubbing the bevel, and I lift up the handle till I get cutting. You can go in either direction. And I'm not moving my hands to make the cut, I'm moving my whole body. That noise means it's not round yet. Now, you can cut with the center of the tool, like I'm doing now, with the fluid at about 45 degrees. You could actually get a better cut if you turn it all the way over to 90 and you use the edges. Okay, it's fully round. The surface is not perfect, but that's okay. It's not worth cleaning up. If you look carefully, you can see the glue joint right there. Okay, so now I'm going to measure this. Actually, to make this thing, it's more time spent measuring than it is turning. And you have to make sure that you bring in your calipers from the garage to the warm workshop before you start, because that'll be about, I don't know, 3%, 4% error. Okay, that's 44.99 millimeters. That's pretty close to 45, so I'll stick with that. So half of that would be 22.5. So I'm going to call this amount of wood here as waste wood. I'm going to measure to the midpoint, which would be here, and then here. Okay, so about this much waste here. So I'm going to put a W here, W there, just to remind myself. All right, I missed that. Double check my measurements. Okay, so what I'm going to do now, I'm going to make a double cone. So this, from here to here, will slant in a straight line down to a point. The same on this side. Okay. So before I start, I'm going to mark these, the parting tool. By the way, to use the parting tool correctly, you anchor it on the bevel. You anchor it on the tool rest, ride the bevel, and then you lift the handle to make it cut. You don't just plunge in like this. Okay. Double check these measurements. Okay, good. I need to cut a little bit more on this side. Try the bedan for that. Same thing, anchor, bevel, raise the handle. Again, I'm double and triple checking these measurements because the actual turning goes quickly and it's better to spend the time up front. Okay, so that's about right. I'll start removing moving the corners now. Anchor, ride the bevel, turn it, cut. Especially when you're starting the cut, you can get a catch. That's all the more reason to follow the ABCs of anchor, bevel, cut. Also, to start the cut, I frequently come way over so that the flute is 90 degrees. Just come in a little bit and then turn it, open it up, and cut. Okay, remember now, this is going to come to a point. So it's going to actually separate from the wood when I get closer. I'm going to just open that up just a little bit to give me some. Now with the ruler, I'm checking to see how straight I am. And I see I have a slight bump at about halfway down, but it's pretty straight. A little bit of extra wood at the very tip. So I am going to now remove this waste wood on the tailstock side. Remember, the tailstock not truly needed because of the clamping here, but before I do that, let me just double check to make sure it's tight. Checking once more. Now I'm checking for linear, and I can see some light between it, so there's a little bit of a bump here, but it's pretty small. I should be able to get rid of that pretty quickly. For these minor changes in shape, I'm going to confess, I'm going to cheat. I'm not going to do a bevel rubbing cut. Instead, I'm going to do some scraping. That's pretty good. I don't know if you could see that. It's touching at the tip, and it's touching there, and there's a little bit of gap in between. So I'm going to remove a little bit at the tip, and I think we'll be done. Now that's excellent. Okay, now I'm going to do this opposite symmetrical cut on the headstock side. Anchor, routing the bevel, lift the handle till it cuts. Now this is still my marker that tells me where I have to get to. Okay, when I get close to the tip here, I try to be very careful I don't catch. Move my marker down. Okay, as this gets skinnier and skinnier, it's going to be less and less stiff. So I'm going to switch to my own live center. This is a Nova live center, and you can see the cup there. So that's going to go over this like that. Okay, and to prevent marring, I've got some shelf liner. This just provides some stiffness. Don't want to press too hard because it'll break, but just enough to provide some support. I tell you, this Nova Live Center is very versatile. In addition to these points, you could actually machine wooden pieces that fits in here and provides another soft version. And if you hit the tool onto the wood, it's no great loss compared to hitting the metal. It also has other pieces that go with it. Okay, now this is a 3/8 gouge. It's sort of hanging over the tool rest a little bit more than I'm comfortable with. Switch to my bigger spindle gouge. This is a Michael Hasselhoff tool. This is a 5/8 diameter gouge. It's the same ground to the same geometry, but it's because it's thicker, it could hang off the tool rest to a larger degree without vibrating. I'll check the measurement once more. Okay, it looks like I lost the length. It's really, this will be closer to the actual length here. Okay, I got to work on this right at the biggest diameter here, and the rest looks pretty straight, but not quite. I'll work on that first. By the way, all of these plans that I had today, plus my references, it's posted on our website. Before I cut it off, I want to double check the profile. Yeah, there's a little bit of bump right at maybe 1/4 of an inch from the top. Oh, it broke off. Not bad. This, because it broke off before I was ready, it's a little bit rough. We'll be able to touch that up after it's glued together. This is just a sharp knife. And because my eyes are 60 years old, I need magnifiers. Okay. There it goes. Okay. All right. So, the way it was turned, and I'm going to rotate it like this and glue it together. Okay. So if you look at this, if you rub your finger here, you see it's the left half and the right half match pretty good. It's going to be a good one, even though it broke before I was ready for it to break. Okay, so how I clean up, there's brown craft paper on both cut surfaces. I can't do this with a disc sander or a belt sander because it's really hard to grip, and you'll grind your fingertips away before the, all right. And don't ask me how I know that. All right, so basically I do it. This is 80 grit paper, 4 strokes, rotate it. And then I do some circle. I look at it, it's pretty much gone. Okay, so I'm going to leave one with paper, one without, and I'll glue this up. Well, I'll show you how I glue it now. You've seen enough of these. Okay, now, there's 2 ways to glue this. One way is to put CA glue on one side and accelerator on the other. You put it there, and the trouble with that is you have about 3 seconds to put it together before you can't adjust it anymore. And I'm not that good. So what I just use regular white glue. You don't need that much. Make sure both sides have it. Okay. Then rotate it, make sure it's correct. Then I use rubber bands. The best rubber bands I've found are these fat ones. They come on broccoli at Giant Eagle or Mark's. I don't know. So I had to eat a lot of broccoli for this presentation. Asparagus I have. This is this one. Okay. Yeah. Tell you, the last demonstration I did was on hollowing, and I had to use the long red spoons from Dairy Queen. And I thought the Dairy Queen sacrifice was a little bit more tolerable than the broccoli. Yeah. Yet I had to eat about 8 blizzards. All right, so you line it up. You get the rubber bands adjusted. White glue or carpenter's glue in general takes about 15-20 minutes before you can be confident that it's going to stay where you want it to, and then you have to again leave it overnight to be confident it's fully dry. All right. So tomorrow I could sand this. I have examples that I've prepared in advance, but I'll show you how I sand them later on. Try not to push on it. Okay, so when you're done, it's going to look like this. Okay? All right. Now, the other thing about many of these, is when you roll them on the floor, they wobble in a kind of fascinating way. Let's see how it works. Yeah, that's it. And they all do that in different ways. And this is too slippery of a surface. Yep. Okay, let me try it with this. All right, famous last words. You see, this works this piece of shelf liner protected the other side. I got enough wood here that I could make an equilateral triangle. Since it's so fast, I might as well do that. Okay, right there, it's 49.7 times 0.866 is equal to 43 millimeters. So that would be right about there. Damn, it's almost perfect. Okay, define that edge, anchor, bevel, raise the handle to cut. Alright, then switch to scraping, get the exact dimensions. Okay, it's touching only in the middle and not at the top or the bottom, so I got to get rid of material from here to here. Actually, you could feel it, there's bumps. Okay, same thing. Now the still not touching the top and bottom, but the middle 80% is flat. So but I have to remove that middle 80% down about 1/10 of a millimeter. Okay, that's pretty good. There's a little bit of deviation at the point, but I want to get onto the spherical kind, so I'm going to take this out and claim victory. Now, I just realized I did a stupid thing. I should have parted this off. Well, I could use a handsaw on that. If I had a vise to hold it on, it wouldn't be that big of a deal. But okay, so now we're going to make the one with the circle cross-section on it. It's called a Fem Sphere. The guy who invented it named it that. I guess the word Hemisphere is feminine. It comes from the root for feminine. He thought it looked like a feminine form. I guess because it's smooth curves, I guess. Make sure the point gets in there. Lock it up. Okay, so right here is the glue line. So I'm going to make it round, and then I'm going to start doing the measurement. Okay, back to the spindle roughing gouge. Same thing, ABC, anchor on the tool rest, rub the bevel, and then raise the handle to cut. I'm rubbing, but not cutting, raising the handle. Okay, now to make it even diameter, you put your finger on the tool rest. I turn the tool gouge, the gouge way over on its side to get a peeling cut, and I make sure that the finger is guiding the cut. Smooth, and the quality of the cut is very good. A little bit of tool grooves still seen, but that is not a problem. A little bit of a dome shape, but I'm going to live with that. I do everything in millimeters because the math is easier. You don't have to turn eighths into sixteenths or anything, because you're dividing by 2 a lot. This is 72.76. So I'm going to reduce the diameter to get exactly on an even number, 72. All right, I'm at 70. So half of that is 35. I'm going to make some waste wood. So the first line I'm going to draw is for the waste wood. That's the center. Okay, and there's the waste wood there. I'm right here, and I'm right there. All right. So now, on that sphere, you have to decide on how thick the walls are going to be. So I'm going to go for a thin one that's going to be 3 or 4 millimeters. So I'm going to mark 1, 2, 3 right there. And 1, 2, 3 right here. Use a sharper pencil. Alright, that's about 5, so I have a little bit of slot or margin there. It's 5 millimeters on each side. So the other thing I'm going to be checking the diameter. It's going to have to be equal to, if this is 3 on each side, that would be 6 total. 4 on each side would be 8 total. So I'm going to go for 8. So I'm going to mark this at 8 millimeters. So I'll be checking this diameter with this calipers. Okay, now, this diameter was 70 millimeters. Divided by 2 is 35, and you minus 4. Hello? Yep. Minus 4, so it's 35 minus 4 is 31 millimeters. So that's the diameter of the template I'm going to make, 31 millimeters. Before I do that, I want to check this number here. Okay, I got to remove a little bit more on this side. All right, for these templates, 31. So it takes time to get this template properly. The better, more accurate this is, the more accurate you're going to be when you're turning. Okay, so I'll put this right here. Okay, double check the measurement. 41, very good, minus 10, okay. So I said you had to go back to 10th grade for your geometry. Just wonder how far do you have to go back to do cutting properly. Alright, and I write the dimensions on this because I might reuse them at some time. That's pretty good. Alright, so I'm going to remove wood in this curvature to make like a star shape on both sides. And when this matches up perfectly, I'm going to be done. As you're making this cove, you start out, and as you progress down, you are opening up the flute. Now, I really don't need to maintain this measurement from the waste wood to the real wood because the template should compensate for that. See, I have a long way to go. This has got to go way down. Can't even fit the template in there yet. Yeah. Okay, there's a lot of wood that needs to be removed from here to here. However, you'll see here that spindle cut with the scourge, with bevel rubbing, and going from large diameter to small and downhill, the cut quality is excellent. However, I'm not good enough to get the shape right, so I'm going to switch to a scraper. And I experimented with several scrapers. Actually, my hollowing tool, it's just a miniature scraper, really. It's a 1/4 inch or 3/16 or a 1/4 inch diameter, or thick. It works pretty good. And friend of mine at work, he gave me this piece of high-speed steel. It's like a 1/2 inch square, and I ground it into a negative rake geometry, put it into this pipe, and this works pretty good. And the negative rake will allow the surface to be maintained as better than the other scrapers. But the real reason I chose it is because this diameter is sort of like perfect for getting into this curve. So I like it for that. A negative rake scraper you use with the tool horizontal. Any scraper could do this. Actually, 80 grit sandpaper could do it too. So you can see the shavings are pretty fine. It looks like it's going to be a good cut. So if you stopped now before you match the template, that means you'll have to do a lot of sanding later on. The diameter at this end will be 8 millimeters because there's 4 millimeters on each side of the center. And when you go on the website, you'll be able to see all the calculations I did verbally here. They'll be all written down in that handout. Patience is the key to this one. So the round ones, I find it's easier to do on the lathe. I've made 2 sanding jigs. This is cone-shaped wood with sandpaper glued on it, 100 grit sandpaper. This one is the sandpaper glued directly onto the wood. This one, I put shelf liner in first. So there's a layer of shelf liner followed by sandpaper. Gives a little bit of cushion. Let's try the cushioned one. I never use this one. Switching jackets because I'm going to be using walnut oil in a little bit. And I don't want to get walnut oil on my new smock. So turn it on. Turn the speed down. Okay. Getting rid of the waste wood first. This is 100 grit. So there's a little bit of excess wood on this side compared to this, but not anymore. And if your diameter is not right, you can move up here or go down here depending on what you need. All right, that's it. All the glued surfaces are now even. So now I switch to the drill press. I'll start with 120 grit with dry. Okay, so there's still a little nub from here, so this is 220, 320, 240 I mean. I need the walnut oil. Okay, you know that walnut oil from the grocery store is not appropriate for woodworking. It doesn't cure. It stays soft. But the couple different manufacturers, this one is called Doctor's Woodshop, there's others, they heat treat the oil in some way that allows it to cure. Okay, that means it hardens and becomes a real finish. I like walnut oil because there's no solvents in it, there's no chemicals, you're not exposing yourself to things that you don't need to be exposed to. Wet sanding has the big advantage is that you don't have to have dust protection. Okay. So, covered it with walnut oil, put the excess on here. Now you're going to polish the whole thing. You notice I didn't do any sanding on the lathe for the bulk of the shape. So I'm going to cover the entire surface with 240 grit with wet sanding. Then I'm going to switch to 320. The biggest trouble I'm going to have is I'm going to remember what I sanded and what I didn't sand, because there's no obvious sides to this anymore. It's one continuous curve. Maybe I'll do just one side, pass it around so you can see the difference. People with nut allergies will almost certainly not be affected by this walnut oil because it's been heat treated. Okay. Although the manufacturers are scared to certify that. I don't know how they would even do that. Yeah. pretty much done. Do the broad surfaces just to be sure. Okay. All right, so that's 240. Pretty much, what was that, 3 minutes, 4 minutes? By the way, the paper I use is square cross-section. I don't buy the discs. I buy big rolls, and I cut it the size of the paper cutter, the kind that you used to see in school, the big lever arm. And I make about, I don't know, 20 or 30 of these in like 5 minutes. Then I have a big stack of them, 2-inch and 3-inch. And then sometimes I hang it over and make them extra size, so it just hangs over and it provides like a soft blending function. Okay. See, I have 2 sets of these. Okay. Big 2 and 3-inch. And also, you could have used something like this. Okay, in the drill press, or on the lathe with the Jacobs chuck. All those things work. I think those cone shapes are better than this. They provide a little bit more flexibility. But I could have done the whole thing on the drill press with this. And I guess the bottom line is the better you're doing in terms of matching the template, the less sanding you'll have to go. But even this one, wasn't my best. It still only took 5 minutes to smooth it out. And I'll tinker with this another 10, 15 minutes to get it perfect, and then switch to 320 and then be done with it. Now, walnut oil takes a while to cure. You have to let it sit for several weeks. In the summertime, you can leave it out in the sunshine. That seems to work pretty good. I told Dan Maloney that he put his bowl out there, and a squirrel came and chewed on it. So I'm not. The other thing is you could put it in your oven. If you have a warming function on your oven, mine goes down and holds at, I think, 140 or 150 F, and put it in for 4 or 5 hours, take it out, it's probably going to be cured. But, so I do all those things, and then I'll buff this. I've never buffed something this small. I don't know how easy it's going to be to hold on without the buffing wheel grabbing it, but it might not need it. It might look fine just the way it is. But I think this is the most difficult shape to sand, and you'll probably want to look at this before I do much farther to see where it looks really nice and where you see I need to do a little bit of work. Some facets that I got to round over. This is a 1/2-inch square chunk of steel. No, it's not glued in there. It's just a set screw right here. Yeah. And I really have never used this before. I was looking for a small scraper that would fit this radius. This is a tiny radius here. So easy wood tool, it would work. However, this is cut, but guaranteed cleaner cut than a carbide, any type of carbide, because of the negative rake and the burr that's on here, because it's sharpened with a burr. Okay. Even a regular scraper, I find I could do a regular scraper without the negative rake, but tilting it down, and you get a pretty good surface, better than a carbide tool. Now, a Hunter carbide would probably work. I've never used that as a scraper, though, only bevel rubbing, and I cannot do a bevel rubbing cut to match a template yet. I need to practice a few more years.